Okay, in this video we're going to look at what happens when you use the factor theorem for complex roots. If x minus a is a factor, then the polynomial with a inputted instead of x will equal 0. But what if a is a complex number? So we'll take this polynomial and we're told that 5x plus I is a factor. This means that the polynomial with a inputted instead of x should equal 0, but what will a be? If we just rearrange, we can find that x will have to be equal to negative I over 5, so we'll input that as our a value. So here we'll plug in our a value of negative I over 5. Just a bit of algebra, expansion. That I squared will become a negative 1, so it'll be negative 5 over 25. Just expanding this bracket. This is all just algebra, but being careful with our negative signs. That will simplify. Negative 5 over 25 will simplify to negative 1 over 5. You can see a lot of like terms can cancel off and that equals 0. So we've proved using factor theorem that there is in fact a factor of this polynomial. But what's the other part going to be? Well, we've got some other linear term, ax plus b. We just got to find what a and b are. Now there's only one squared term on the right hand side, that's 5x squared, and looking at the left hand side, the only place that can come from is when we multiply these two parts. So 5x times ax has to equal 5x squared. This leaves only a equals 1 as a possible value for the a value. Once again, the constant term, negative 3i, can only come from multiplying I and b, which leaves us with b having to equal negative 3. So our other bracket will be equal to x minus 3. So if we fully factorize this polynomial using factor theorem, we'll arrive at 5x plus I and x minus 3, giving us x equals negative I over 5, or 3 is our possible answers, our possible roots. Right, now for a bit harder example, we're going to factorize using factor theorem again. It's going to have 3 brackets because it's a cubic, and we're not told any of the factors at the moment. The last number in each bracket will have to multiply together to give the constant term, and the only factors of 9 are plus or negative 9, 3, or 1. So we're going to try plug in a few of these values and see which ones work. Right, so here's our polynomial, and I'm just going to plug in using factor theorem and the remainder theorem to see if any of these are factors. So we'll try 1 first because it's the easiest one. Expand out, that's 1 plus 3 minus 2i, and this has to equal 0 and it doesn't, so 1 isn't a factor. Right, I'm going to use a bit of foresight here to try negative 3. We could have tried a whole bunch more, but I wrote this question, so we'll try negative 3. Just being careful with your expanding and your squares and negative numbers. Already looking a bit more promising. Now we'll cancel these off. You see all these terms cancel off and it equals 0. So therefore we know that negative 3 is a factor. So we're going to try and figure out the other brackets. But we know the first bracket, well, if x is equal to negative 3, well, x plus 3 is going to be one of our brackets. And because it's a cubic, that means that this bit left over here is going to have to be a quadratic. And there's going to be 3 values we have to figure out. So I'll just bring this over here. You can see that we're only going to get the x cubed term because it's the highest power. That's only going to come from when we multiply the highest power of each bracket. So we can know that ax cubed will equal x cubed. And that will tell us that a will have to equal 1. Similarly with the lowest power term, the constant term 9, that will only come from 3c equals 9. So c will equal 3. So we've worked out a and c. So we've done this from working with our highest power and our constant term, our lowest power. But we've still got to work out b, so we can do that from x squared or the x to the power 1 term. So let's look at the x squared term. We know the right hand side is 3 minus 2i times x squared. X squared terms on the left hand side come from 3 times 1x squared, but it also comes from x times bx. They're both x squared terms. So if we combine them, we can see that 3 plus b has to equal 3 minus 2i. So b has to equal minus 2i. We can just see that from inspection. So we know that the quadratic term can be written out as x squared minus 2i x, that's our b term, plus 3. And we'll just use the quadratic formula to work out how we can break this down into its two factors. Negative 2i is positive 2i. We'll just have to be careful once again when we input negative 2i squared that we deal with that correctly. So that's 4i squared minus 12. So that 4i is going to become 4i squared is going to become a negative 4, and that will all factorize. Negative 16 will factorize to 4i. So if we take the plus, it's going to give us x equals to 3i. So if x equals 3i, our bracket is x minus 3i. And if we put the minus sign in, 2i minus 4i, that's all going to simplify to negative I. So our final bracket here will be x plus I. So these are our three solutions, and we did it using the factor theorem